Hi everybody, I'm Bill Hall, and the mathematical concept we're going to look at today is linear programming, and we're going to look specifically at why students have difficulty with this concept and the strategy that we as teachers can use to address these difficulties that students sometimes have. So, why do students find this concept so difficult? The answer is that linear programming problems typically throw a lot of information at students all at once, and that's going to be illustrated quite clearly in the next slide. There's going to be a lot of information here, and I'm including it all to make a point. So here's a lot of information thrown at a student all at once. So you are running a manufacturing business, and you have two raw materials, raw material A and raw material B. You have 12 units of raw material A, and you have 24 units of raw material B. If you combine 1 unit of raw material A with 4 units of raw material B, you produce a unit of product C. And if you combine 2 units of raw material A with 2 units of raw material B, you produce a unit of product D. Product C sells for $4 per unit, and product D sells for $3 per unit. How much of product C and how much of product D should you produce for maximum profit? That's a lot of information thrown at students all at once, and that's very typical of linear programming problems, and that's why students find them so frustrating. So, having read that, are you feeling a bit overwhelmed? That's how students feel too. So in terms of strategies, how do we as teachers help students with this kind of problem? The answer is we teach students how to take it step by step, and there you see some steps there. So step one, reread the problem and make a list, and in this list, only write down things that have to do with raw material A. So if we go back to the problem, here are the things in this problem that deal specifically with raw material A. You have 12 units of raw material A. You need 1 unit of raw material A to make a unit of product C. And you need 2 units of raw material A to make a unit of product D. Those are all things that specifically have to do with raw material A. So we write all that down. You have 12 units of raw material A. It takes 1 unit of raw material A to make a unit of product C, and it takes 2 units of raw material A to make a unit of product D. Now you can write this equation. So X stands for product C, and it only takes 1 unit of raw material A to make a unit of product C. So imagine a 1 before that X. We never write that 1, but it's sort of there. The 2 is because it takes 2 units of raw material A to make a unit of product D, and the Y stands for product D, and all that equals 12, and that's the 12 units of raw material A that you have. So you distill all of these words into an equation. And now you graph the equation. I'm not going to get into the mechanics of how you graph that, but if you graph it by intercepts, that's what the graph would look like. Now, you've dealt with raw material A. Now you go back to the original problem again, and this time, only write down things that have to do with raw material B. So if you go back to this problem, here's what you know about raw material B. You know you have 24 units of raw material B. You know it takes 4 units of raw material B to make a unit of product C. And you know that it takes 2 units of raw material B to make a unit of product D. So you just write down the things now that have to do with raw material B. It's the things we just looked at. You've got 24 units of raw material B. It takes 4 units of raw material B to make a unit of product C. And it takes 2 units of raw material B to make a unit of product D. So you write this equation. The 4 that you see there is because it takes 4 units of raw material B to make a unit of product C. That X stands for product C. The 2 there stands for the fact that it takes 2 units of raw material B to make a unit of product D, and the Y stands for product D. And the 24 is the total stockpile of 24 units of raw material B that you have. Now you graph this. And again, I'm not going to go through all the mechanics of how to graph an equation, but if you do it by intercepts, that's what the graph is going to look like. So now you've got a graph for raw material A, and you've got a graph for raw material B, and now you put them on the same graph. And you notice that arrow there is where those two graphs intersect. If you take the graph for raw material A that's to the left, and you take the graph for raw material B that's in the middle, and you put them on the same graph, that area indicated by the arrow is where those graphs intersect. And now we only want to keep the section where the graphs overlap. It looks like this. Notice the graph is going one direction, it turns the next direction, creates a corner, and that is very typical of linear programming problems. Okay. So far we've been talking about production, but now let's talk about prices and profits. So now we're going to go back to that very long original problem, and we're only going to look at the things that have to do with prices. So back to this very long problem, if you look toward the bottom, it says that product C sells for $4 and product D sells for $3. So this time, out of all of that stuff, you're only looking for the prices of these two products. So here we go. Out of that whole long problem, all we're focusing on now is the price of product C is $4 and the price of product D is $3. And now we're going to draw a profit line. And the slope of that profit line is the negative ratio of the prices, negative 4/3. So product C was $4, product D is $3. We're going to take the ratio 4/3 and the negative of that ratio, negative 4/3. So we've drawn a line now, and the slope of this line is negative 4/3. Now, we're going to move that profit line around, but we're going to keep the same slope. So the constant here is that the slope of this profit line is always going to be negative 4/3. And now we're going to move it kind of back and forth, but notice as we move it back and forth, the slope is staying the same. As we move this profit line further from the origin, it means more profit. As we move that profit line closer to the origin, it means less profit. So we want this profit line to be as far away from the origin as we can. And again, we're always keeping the same slope. So remember, that's our objective, to keep the profit line as far away from the origin as we possibly can, because that's going to be the highest profit. All right, now we're going to put some stuff on the same graph. On the left, you see the production line, and notice that characteristic corner that it has. So that's what we can actually produce. And in the middle is the profit line. And again, the slope of that profit line is always going to be negative 4/3. And on the right, we've put those two things in the same graph. So you've got the production line with its characteristic corner, and then you've got the profit line further away from the origin. Now remember, we want the profit line to be as far away from the origin as we can get it to be. So what we're going to do now is we're going to take the profit line, keeping the same slope. We're slowly going to move it toward the production line until it just touches. We want to keep it as far away from the origin as we can. So as we have this profit line and we're moving it toward the production line, as soon as it touches, we're going to stop, because that's the highest that we can have the profit line. That's the furthest away from the origin that it can be, and hence the largest profit. So we're moving this profit line as indicated by the arrows. We're moving it closer and closer to the production line. And as soon as it touches right there in the corner, we're going to stop. And that's going to be our point of maximum profit. So remember this big, long problem that students find frustrating. I'm not going to read through it again, but that's a lot of stuff that we're throwing at students all at once. And students find this very frustrating. The strategy that we as teachers teach is just take it one step at a time. First, you just look at raw material A. Then you just look at raw material B. Then you just look at prices. And finally, you put all of this together. You see the production line with its characteristic corner. You see the profit line that we're moving toward the production line until it just touches. And if we take it step by step, we can teach students how to do a linear programming problem in a way that's not going to be so frustrating. So that is my presentation for today. Thanks for your attention.